As you can see, today's session will be going over curved steel composite eye girder bridge design, and we'll be going off of this tutorial, which we'll supply later on. But just keep in mind that the steel module is a relatively new sort of addition to Midas Civil, so we're very excited to share it, and we're very excited for a lot of our users to start taking advantage of it. So for this particular project, I'll be using this curved eye girder bridge as sort of a sample. So what I won't be doing is I won't be going too in-depth into the modeling methodologies, just because during one of our previous sessions we went into sort of detailed step-by-step sort of process of going through the modeling functions and features. But what we'll be focusing on will be composite steel girder design, the cross-frame design, and also the pier and the pier table design. So I'll be going over that very sort of slowly, step by step, so that those of you who are new to the program can really sort of pick up the process, and hopefully you guys can get started using it for your own projects as well. Oh yeah, another thing that I'd like to make note of is that if you have any questions, we definitely welcome any sort of questions, except that we just prefer that you send them at the end of the webinar. What I'll be doing is I'll be providing my email address. That way you can send me any sort of questions or comments you have, or any feedback also about the presentation. So I apologize that we can't sort of field questions in the middle of the presentation. It's just that there's so many engineers here, and we just really want to make sure that we go through all the material in a timely manner. Okay. So here's just sort of page 2 of the overview of the tutorial, and just goes over the specifications of the project as far as the bridge type and the material properties are concerned. Here's sort of like a brief sort of overview of the bridge. It's 2 spans, has 2 piers. This is the curvature. And one thing that I also want to make note of is the loads. So here we'll be dealing with a couple of sort of separate loads. So as you can see, we have DC 1-1, which is a self-weight acting on the non-composite section. So just keep in mind that this weight is to be assigned to prior to the deck being poured on, or the composite deck being added on. Whereas DC1 subspace 2, wet concrete weight acting on the non-composite section, that's when after the concrete deck has been poured. So there's something that we'll be doing during the presentation is we'll be separating these 2 loads into these 2 separate load cases. Okay, and then of course we'll be going according to AASHTO LRFD, and I'll show you how specifically to go about doing that, to go about specifying that design code once we go to the design section. Okay, so as far as the modeling methodologies, what I'll do is I'll just sort of skim over this pretty quickly. So there are 3 sort of major modeling methodologies that are listed in the tutorial. One thing that's really important to remember is that even though the modeling methodologies that you use may be different, ultimately they don't affect the steel design process. The steel design process and the results that are generated will be uniform regardless of the methodologies that you use. So these modeling methodologies differ according to the sort of analysis type that you want to run. So as you can see, this one has sequential analysis plus an accurate time-dependent material, whereas the second one has a sequential analysis with a long-term modular ratio of 3n. And the last modeling method is a composite action without the sequential analysis. So depending on just sort of your project specifications, or what you're sort of dealing with, you may want to go with a certain analysis type. And in this tutorial, it spells out how specifically to go about doing that. And what we'll do is we'll provide you all with sort of access to these tutorials later on, so that you can try them out for yourselves. But when it comes to composite girder design, so now once all the modeling is done, what you do is you run the analysis, and then you go through a certain design methodology. So first, let's go over the composite design. Okay. So here, as you can see, I'm in Midas Civil now, and this is the completed project, or the completed model, actually. Here's sort of the full view. As you can see, we have our composite deck modeled on top of the girder. Okay, we have 2 piers, which we'll be designing as well. And we also have a series of cross frames. Let me see if I can zoom in for you, which we'll be designing as well. And keep in mind that nodal connectivity has been established with the piers and with sort of the superstructure via rigid links. Okay, and then last week we talked about seismic isolators, but I don't believe you have any for this particular project. Okay, so going into composite design. So just keep in mind that this composite bridge is one where reinforced concrete deck, or when the slab sits on top of these steel I-beams, and it acts compositely, with them in bending. Okay. So first thing we need to do is we need to define the longitudinal stiffeners. So in order to do that, first we just have to go and check the elastic modulus ratio. So you can manually define the effective width scale factors to consider the long-term effects like creep and shrinkage for composite sections, or you can use the section data dialog box. So if you go here under property, if you go to section properties, as you can see, it takes you directly to this tab over here. So let's check out section 1-1, okay? And 1-1, so let me take a step back actually. And so you see here, and actually let me turn the hidden view on. As you can see, section 1-1, these types of girders handle sort of the inner parts of the span, whereas section 2-2, section 2-2 over here sort of represents, or they're modeled over the parts that are closer to the pier and to the abutment for optimization. Now, going back to what I started originally, we have to go here and we have to sort of modify the ratios for our design. Okay, so if you open it up, as you can see here, what we have here, and actually this is something I've already done previously, but just to sort of go over here, as you can see, multiple modulus of elasticity. As you can see, what you do is you modeled it on for the creep, and then what you do is you do 3n, or 3 times this ratio, to plug in your value. And let me sort of re-enter it here. So it's 23.8749. Okay, so we did that for the first one, and then we have to do the same thing for the second section too. Just go in here, 3n, and it's 23.87, and that's for creep. Okay, so once that's modeled, or once that's modified, the next thing we need to do is we just want to double check our effective width scale factors. So to do that, just go to Properties, go to Section Manager, and then click on Stiffness. Okay, so what happens is this input menu will come up, and as you can see, all of your sections are listed over here to the left. So let's check on section 1-1. Let's turn on or select one of these elements here, and as you can see, it's all listed here as far as the stiffness for each element. You can go and you can view and you can make modifications as you need. So that's section 1-1 and also section 2-2. The same principles apply. Okay, so that's how you go about checking your effective width scale factors. Okay, so now we want to go and input our span length information. So ultimately, span information is required for the program to distinguish the end and interior panes. So you need to separate shear check formulas that are needed for the panels depending on where they're located. So span information, it's used for viewing the composite design results and the result diagram as per span. So ultimately what you're doing is you're going to be separating your spans, or you're sort of defining where they're going to be for your analysis. So first, in order to sort of delineate what your spans are, go to Structure, and then go to this option here, Composite Bridge. So just as a recap, this tab here has all the functions that are needed in order to create sort of, well, here's your sort of wizard section. So this allows you to create, to enter a large series of commands very simply, or very sort of quickly. So what you can do is you can actually build sort of larger, more complex structures with a limited amount of commands. It's very useful. So for composite bridges, we have this specific tab specifically to help you model composite bridges more effectively. Okay. So as you can see here, this sort of input menu will come up. So what we want to do is we want to select a certain number of girders or a series of girders to represent a certain span. And actually, let me give you a preview of what we're going for here. So as you can see, what we want is something like this. As you can see, each span has a left and a right. So span 1 left, span 1 right, span 2 left, span 2 right, etc., so on and so forth. So what we need to do is we need to create a series of selections for each of these series of girders. Okay, so there's going to be 8 in total. Okay, so what I'll do is I'll create the first one for you, just to sort of show you how it's done. So first, let's do span 1 left. Okay, and then we're going to select our elements by number. So you could select them element by element, but since this is a curved structure, it might be a little difficult to select all of our elements. And then actually, as long as you have the span or the element numbers, you can actually do a shortcut and just enter them sort of as a series. So if you're not sure of what your element numbers are, what you can do is you can just turn this option on. So as you can see, all of the elements are numbered now. It's sort of harder to see, but if you zoom in on like this section over here, as you can see, each of our elements has an individual number. So what you can do is, instead of having to select them individually, this is that would be a tough thing to do if you have a large structure. What you can do is you can just enter the series here. So let's say, for example, and let's zoom out. Let's turn this off. So I already have the numbers sort of spelled out just to save time. So my first set of elements will be element 98 to 111. All right, and if you want to double check just to make sure that you're getting the right element, go here to query, okay? And then go to query elements. So this option will come up. Now let's type in element number 98. Press enter. Now as you can see, it'll hook it out over here. And actually, let me unselect everything else so you can get a better view. So there's element 98, and then element 111 goes over here. So that's that first span, right? And then I'll also enter element 436 to 449. Okay, so just add replace. So now they're all listed here. Perfect. And then what we'll do is we'll change the supports at the ends. So element number 1, we'll change that to I. And then element number 28, that'll be J. Okay, so once that's done, just click add, and now you have it listed here. So now we'd have to do this like 7 more times just to make sure all the spans are listed. But once again, I just want to save you guys some time. So what I'll do is I'll open up an alternate model file where I've already completed all the spans. Close this. Okay, so now let's go back to our options here, our span information. And as you can see, I've modeled everything all the way up to our 8th and final span, span 4, right side. Okay, so there we go. So now let's move on into the next step here. And now we're going to modify our construction stages. So I said at the beginning that we have we have to take into account sort of creep. So we need to specify that in our 3rd and final construction stage. So when the cement's drying, we want to take into account the effects of creep. So just go to load, and then under load type, as you can see, you have all these different load types to choose from. And as you change the load type, this ribbon menu over here changes. So each of these load types has a specific set of functions and commands that are unique to that load that you're selecting. So what we want to do is we want to select construction stage loading. Let's go over here, and then we'll go to define construction stage. So as you can see, I've already defined all of my construction stages 1 through 3. Let's go to the 3rd stage, which is where the concrete deck has been poured and when it's drying. Let's go to modify. Okay, so the creep functions, they act as boundaries. So what we want to do is we want to go to the boundary tab. Now as you can see, I have creep 1 and creep 2. So all I need to do is select these two and then add them or activate them in this third construction stage. So now the program will recognize that these two boundaries, these creep boundaries, will be activated during that 3rd construction stage when that deck has been poured. So once that's been inserted, just click OK. Okay. So now that we've taken our creep into account, let's move forward and let's define our construction stage analysis control. So let's go to Analysis, and then let's go to Construction Stage. So this tab over here. And keep in mind that what this tab does is it prepares your program or prepares your model for analysis by allowing you to specify certain controls or certain modifications. So that way, your analysis can take into account certain things that need to be recorded or that need to be sort of delineated prior to going through all the calculations. So here we have construction stage analysis. So this big input menu comes up, but the main thing that you really have to focus on here is our load case name. So something I specified earlier at the beginning was we have 2 different sorts of sort of dead loads or composite loads. One's going to be activated prior to the pouring of the deck, and the other one's going to be poured or activated after the deck has been poured. So we'll do under load cases to be defined. So as you can see, currently we don't have any load cases to be distinguished from dead load for our construction stage output. So what we'll do is we'll click Add, and then we'll define our first load case. So let's name that first load case DC2. Whoops, DC2. And as you can see, it's not just a dead load though; it's dead load component and attachment. So DC. And then what we'll do is we'll bring this over into the selected load case or the activated section. So there you go. So now the program recognizes that there's a load case with this name. It's this type of load case, and it has this sort of load. Click OK. So now what we'll do is we'll separate the second load case. So we'll add our second one, and we'll name this DW. And then what we want to do is we'll go here, and then this is the dead load of wearing surfaces and utilities. So after the deck has been poured, so we'll put that. And then next we'll put our DW load on. So we'll bring it over, and then we'll click OK. So now we have our load cases separated here. Okay. All right, so now that, after we've separated our load cases, our next step would just be to run the analysis itself. So in order to do that, just go to Analysis, and then Perform Analysis. So, the Midas Civil has a fairly robust post-processor, and this is, a fairly straightforward model, so the analysis should be done within a couple of seconds. As you can see, it'll update you as its progress is going. Right now it's just doing the moving load analysis. And the reason the moving load analysis takes longer is obviously just because of the multiple load cases that you're using for moving load. Okay, there we go. So once it says solution terminated, that just means the model has finished running. So the analysis is complete. So what you can do, as you can see, is you can go to results. You can get all of your, for example, your forces, your deformation, etc. So I went over how to go over these types of results in Tuesday's session. So I won't dwell on them today. But if for whatever reason you have any questions about how to find results or how to extract results, feel free to just contact me after the webinar, and I'll address your question personally. So now that you've run the analysis, the next thing we want to do is we want to go over the design section, which is that new function or that new feature that we're trying to share with everyone that we've been having a lot of success with so far. So first, the thing we need to do. What we're going to do our composite section design first, and then I'll do our cross frames and our piers. So the reason I'm doing composite section design first is just because it's the longest. It has quite a few steps, so just don't worry about remembering everything. Just try to remember the general flow, and then later on when you're doing it on your own, you should have a a firm understanding of where to go and how everything is set up. So you don't have to remember each exact step, but just remember the basic process. So first thing you need to do is you need to go over your load combinations. You need to define them. So go to results here, and then go to this tab all the way here to the left, the load combination. So click on that. Okay. And then as you can see, I have several different tabs here. One for steel design, one for concrete, one for steel reinforced concrete, and one for composite girder design. So first, because we're designing our composite sections, go to composite girder design. Let's click on that. And then the next thing we will need to do is just click on auto generation. Okay, so now as you can see, this input menu will come up. So you need to make sure, first and foremost, that your design code is correct. So as a default, it's set to ASH2L or V12. But if for whatever reason you need to switch, you have this other option as well. So that's there, so that's good. And then we also want to make sure, because it's a construction stage analysis, not just a simple static load, we set this option here to construction stage only. That's what CS stands for. So once that's selected, just click OK. As you can see, all of our load cases are automatically generated here. So here we have our moving load, our dead load, DC2, which is specified to be prior to the composite deck being poured, or the concrete deck being poured, and then DW construction stage, which is after the deck's been poured. So all of it's listed here. So if all of this checks out, if you want to make changes, you can do so manually. But this is something really convenient about the programs. You have to individually make your cases. It'll all be generated for you via this auto generation feature. So if everything checks out, you can just click OK, or you just click Close. Okay, so that's our load combinations. So now our next step would be to create our composite design parameters. Okay, so what we're going to be doing now is we're going to be going to this tab here, Design. All right. So, this is the new functions are all listed here. As you can see, we have a section for each type of design. One for steel, reinforced concrete, SRC, and also composite design. So let's go to Let's go to composite design. As you can see, what I'll be doing basically, the general flow of the design process is just to go from top to bottom, run the design, and then go through your results. So I don't have any results yet because I haven't run my design. What I need to do first is I just need to specify, or I need to go through each of these options and make sure that all my input parameters match up with my project. So first, let's go to this first one here, design parameters. And as you can see, this input menu will come up. So first, we just want to make sure the code is uniform, okay? And then just click on Update to Code. So now anything that you have, or all your parameters will be updated according to AASHTO LRFD. And also, here we have some options for our strength limit state. So for example, Appendix A6 for negative flexure resistance in web compact or non-compact sections. We'll check that on. Also, positive flexure in compact sections. We'll click that on. And also post-buckling tension field action for shear resistance. We'll check that on as well. So these are certain options that you have for your strength limit state. For this example, let's activate all of them. Okay. So now let's click OK. So that's our first step. So now we go down here to Design Material. So click on this option here. As you can see, here I have SRC. Here's a type of steel. Here's a type of concrete. We'll click on it. And then we just want to make sure that each of our codes match up to the ones that we have in our project. So as you can see, we have ASTM 09, and we also have ASTM RC for reinforced concrete, for grade C 4500, so that checks out. So it looks like so far everything's up to par. Let's make some other checks here. Reinforced concrete, grade 60, grade 50. Okay, that's the web grid. Okay, and as you can see, if you go to these drop-down menus here, all of your options are available right over here. So far, this looks pretty good. For our top flange, okay. Okay, good. So once you're sure that everything checks out, or actually, let me check one more thing. Let's check the hybrid factor. So here's our top flange. There we go, 709. Okay. Perfect. So once again, all the changes can be made via these drop-down menus here. Okay. So all of this checks out. So let's click Close. Oh, and also, if you do make any changes, if you need to change them, or before you close out of this input menu, make sure to click on Modify. Otherwise, your changes won't be saved. Okay. So now under Composite Design, let's go into our next step. Let's go to our Load Combination type. As you can see here, we have our different load combinations, one for strength limit state, one for service limit, one for fatigue, another for our second fatigue case. And as you can see, if you need to make changes manually, you can just do so like this. You can just pull them in here and then pull them into another box. So for example, if I wanted to move this case into this box, I would just do like so. Okay, so it's very simple. Okay, so once you're sure that all of your load combinations are listed correctly, just click OK. Okay, so now let's go and define our longitudinal reinforcements. Just go here, go to longitudinal reinforcement, and now this pop-up menu or this input menu will come up. So as you can see here, if I go to my menu here on the left, I have my two section types, or my two composite section types, section 1-1 and 2-2. So let's open up, let's see. Okay, so what we'll do is we'll apply negative flexure sections to sections 2-2. So let's go here, section 2-2. And as you can see here, we have longitudinal reinforcements or shear reinforcements. So let's go down here. And then let's define our reinforcements. So first, for reference, the Y, let's make it from the left instead. And here, another thing that you might be curious about are the two different input methods. So don't worry about that. There are two different ways to input your reinforcements. So let's just explain method A for now. And then Y, so that's in reference to the left. So it'll be, let's go 3 inches from the left. And then for Z, let's leave that as top. But as you can see, you can choose bottom as well. And then for Z, let's put 4.37 inches. Okay. Now we have the number. Let's put 19. So 19 stands for the number of reinforcement bars. And then the spacing, obviously, is just a spacing between those bars. So let's make it 6 inches. So as you can see, it's already sort of showing up there. And also the diameter, let's make it number 8. And then for the part, let's make it part 2. So part 2 is the concrete deck, and part 1 is the steel girder. So obviously we want it in part 2. And then just click Add, and then click Apply. Okay, so now we have our reinforcement set. So another important thing to remember is that transverse stiffeners are required for considering the tension and field action in interior stiffened panels for the strength limit state check. Okay. So now another thing we want to do is let's actually select section 1-1 as well. Let's define something for this. Let's go to the transverse stiffeners. So for longitudinal stiffeners, it'll only be section 2.2, but for and that's just to save time. Just because in order to put in the stiffener here, you'd have to go through this whole process again, which is very simple. But let's move forward to our next step, which is our inputting our transverse stiffeners. So once again, we're still working under the Design tab, and as you can see, right under longitudinal reinforcement, we have transverse stiffener. And let's do it for section 1-1. So once again, this will come up. Click on Web, or check on Web, and then click on this option here for details. And what we can do is you can select the sort of the type of stiffeners that we want. So let's make it a flat stiffener. And then let's just make 1 stiffener. And then for Fy, for the value, 36 KSI. For the pitch, let's make it 90. For B, which is just the dimension, let's make it 5 inches by 1.5. Okay, there we go. And then just click OK. And then click Apply. And now your stiffener has been applied to section 1-1. Okay. And then actually to make a stiffener for section 2-2 as well, so it'll be the same process. Click on Web, Flat. Let's just punch in these values real quick. So 1 stiffener, a flat type. Fy is 36. Pitch is 90. H and B, or H and T, excuse me, B and T. So 5 and 1.5. Click OK. Apply. So now these both have transverse stiffeners. Now we'll go to Close. Okay. So now let's move forward. And let's do our unbraced lengths here. So in order to define our unbraced lengths, just go to Composite Design. As you can see, we're slowly making our way down to the Design section. So now let's do our unbraced length. And what you can do is you can just specify the unbraced length, which is used for lateral torsional bucketing, to checking Composite Design. So what you need to do, actually, something I forgot to do, is you have to actually select the girders before you can assign our unbraced length. So let's actually take a step back. Let's go to the Works tree, and just go to Section, and just select all your composite girders. So just double-click on one, and then double-click while holding Control on your keyboard, and you can select sort of multiple types of sections. So as you can see, all of my composite girders are selected. You'll go back to Design, or Composite Design, go back to Unbraced Length, and then all you have to do simply is to define the length. So for this one, let's make it 223 inches, and we'll click Apply. As you can see, it's been applied along the entire sort of span or length of the bridge. So that's how we define our unbraced lengths. And now, once again, let's select all of our girders once more. Now let's go back to Composite Design. And let's go to Design Position. Let's go here. And then, as you can see, you can choose either I, J, or I and J. So let's click on both I and J. Click Apply. There we go. Now we're set. Okay. So now we have to decide or to specify the position for our design output. So these positions are locations for which the detailed design report will be generated in the Excel format. So for example, all you're really doing is selecting a certain sort of element. There'll be sort of a type for the other elements for your design. They'll be sort of selected for specifically for your Excel report, because you don't really need to sort of create this lengthy report for each and every single element. Or if you have just a couple of elements of interest, you can specify that with this option here. So to do that, just go to Composite Design and go to Design Position. Okay. And then all you need to do now is select a certain element. So let's actually select element 75, and that's one of the elements here. Let me enter it now. There you go. It's that element. And then what we'll do is we'll select it for position J, and then we'll just click Apply. Okay, so that element's been specified. And then for element I, let's select element 368. As you can see, it's right over there. And then let's select this one specifically for position I. So we'll click Apply. Okay. So now let's go and specify our shear connectors. Okay, another important step. So we'll go down here to Shear Connector, and once again, I'm still in the Composite Design drop-down menu. So Shear Connector. And so for this particular example, connectors will be provided in the negative flexure sections only. So for example, sections 2-2. So what we'll do actually, first we need to select all the composite girders with section 2-2. So we'll go here, select these, and we'll go back to position for, or actually shear connector. And then we'll just select our various categories. So for the shear connector type, and then also make sure that this is checked on at both ends. The I and the J have the same type. So for category, let's select C. And then for pitch, let's make it 5 inches. Then for height, 7 inches. For diameter, 0.875. And then let's make it 60 KSI. Okay. Then also for the spacing of the shear connector, let's make it 4 inches. So this spacing is the transverse spacing between two adjacent shear connectors. Okay. And then also for the number of shear connectors, let's make it 3. And this is the number of shear connectors placed transversely in each row. Okay, so we can leave this as 0. We can leave that as a simple span, not composite. Then we can just click Apply. Okay, so now it's been entered in. Okay, so now let's enter some fatigue parameters. So let's go here. As you can see, we're in this step now, fatigue parameters. Now we have this input menu. So let's select all the composite girders. So actually, let me go back here. Select section 2-2, 1-1, back to fatigue parameters. And then both ends, or both end parts, I and J, have the same type, checked. And then for the category, let's select category C. As you can see, all our categories are listed here. And also for the shear connector, for this value, let's put 1,000. And for the cycle, let's just make one cycle for fatigue. And then just click Apply. There we go. So now all of our fatigue parameters are entered. Okay. So as you can see, the input or the work process is very simple. Simply starting from the top, working our way down, and going through this entire list here, and entering all in our various parameters. So now we're almost to the design section, but first we need to do our curved bridge info. Okay, so the curved bridge information option allows the software to consider the bridge as a curved bridge for composite design. So for example, radius inputted here doesn't really affect the design forces like lateral moment due to curvature. So the design forces, they're solely calculated from the analysis results. Remember that. So let's actually select all of our composite girders again. So I want to apply to that. Go to curved bridge information, and then all you have to do here is just enter in the girder radius. It's 240, and it's concave. So click Apply, and we're set. Okay, so now let's also define our design tables for design forces and moment. Let's go here. Actually, let's take a look at them. So as you can see, everything that we defined, been listed here pretty clearly. So let's take a look at design force and moment. So I'm not going to select everything. I'll just select maybe a couple of sort of arbitrary cases, just so that you can see what the tables look like. And it'll take a second to load. And here we go. So as you can see, it's very sort of exhaustive or extensive as far as the results that are given. has your dead load or your moment before or after, or your short term. It has a moment in each direction as well as the shear, dead, before and after, and the short term. So that'd be how you would check it. So just go here, and once again, just go to Design Tables, Design Force Moment, and you can also go over, everything you've defined previously just by going through these functions here. And then, as you can see, I'm currently in another view. So if you want to go back to your model view, just click on this bottom left tab here, and it'll take you right back to your bridge. And also, this page is saved. For whatever reason you need to go back to it, you can just click on that tab. Okay, so now all we have to do is let's run the design. Let's go here, go to Design. And as you can see, a message window says performing the composite steel girder design. So this will take just a couple of seconds. Okay, so as you can see, the post-processing is very fast, very smooth. And the design has been successfully completed. So let's take a look now at some of our results. So if you want to take a look at your results, once again, you're back in this Composite Design tab. You're in this Composite Design tab, and let's say you want to go over the design results table. So go here, okay, design results tables. Actually, whoops, sorry, I'm in the wrong model. Let me open that one here. There we go. Go to Design. Okay, so what we want to do is we want to just view them in tabular format. So let me go back here. So here we have our design positions. Okay, so let me double check. I think I need to reperform the design. Sorry about the hold-up, guys. Okay. Okay, so let's take a look at a couple of our tables here. So here we have our design positions, our position for design output, shear connector. So as you can see, all of our tables are listed here very clearly. Simple span, normal shear calculations, etc. And then if I want to check the deck overhang loads, I can double check them here. So I don't have any overhang loads, so I don't have to go through that. And then also position for design output, nothing there. Okay. So what I want to do now is I want to go through these design result tables, but currently the option is turned off. So just give me a second here. I think I have something sort of missing. So what I'm doing now is I'm just rerunning the analysis on an alternate file, just so that I can make sure that the results come through cleanly. So what it's doing now is running the preliminary analysis, and then what I'll do is I'll do the steel design check in just a second. Okay, now it's performing the composite steel girder design. There we go. Okay, perfect. So now let's take a look at our span checking. So first, let's go to, well, actually, let's print our results. So let's see what that looks like when all of our results are printed out. So as you can see, you can actually print out all of your results in a very easy Excel report format. So let's go here, let's create a new file. Let's just save it as that. And as you can see, it'll take all of your data and all of your results, and it'll put them into a very sort of easy to, or very sort of well-organized result file. That's very easy for submissions. That's very easy to sort of go over all of your results. So it'll take just a second. Okay, and let me pull it over now. Okay, so here, for example, you have a couple of your design conditions for your composite sections. So everything is listed out here. You have your section properties are all listed out, strength limit states, etc. So everything, all of your sort of preliminary analysis is done. And here you have a couple of sample calculations. And as you can see, if it checks off, it's okay. And also, if there are any errors or if there's anything that doesn't check out, it'll say NG for no good, and it'll be in red, and it'll alert you to that. So once again, as you all know, design is an iterative process. So this program or this specific feature allows you to really cut down on the sort of the repetitive steps and really allows you to sort of work much faster. So as you can see, everything's listed here, all of your sample calculations. So I won't go through each and every one of them, just in the interest of time. But these all should be familiar to you. And once again, with this program, you can really cut down on the time it takes to do these calculations and create these reports. So as you can see, I have this calculation came out okay. This one for this particular section or element, it has an error. So what you can do is you can actually just go back, make your changes, and then rerun the analysis very quickly to see everything that needs to be changed or to see how your adjustments affect the results. Okay, so that's what it looks like in your Excel sheet format. And once again, you can just save it under Enable, be stored in your computer. Okay, so now let's go into, I guess, some more of the specific results here. So let's go into span checking. Let's go here. Let's go to span checking. We'll click on these two, and there we go. So as you can see, whenever I create a new sort of results tab, it'll be listed over here. So here I have all of my spans listed, and so far it looks like everything checks out over here. All this is okay. So now let's take a look at our total checking. Let's go here, go to design tables, design result tables, go to total checking. We'll leave these on, I and J, positive and negative. Give it a second here. And as you can see, our total checking, all of our results are listed here very clearly. So this is one thing to note is that the span checking and the total checking results, they're not available in the design report. So if you want this particular tables, you can only really access them through the functions or through the methods I showed you. So I'm saying you just go here and you just click on span or total checking. And what you can do is you can export these to an Excel sheet format just on your own, just by copying and pasting. So as you can see, it's all listed here. I think positive is in black, negative is in red. So it's all very there in a very simple sort of spreadsheet format. So let's take a look at some of the other results now. So let's take a look at like our strength limit state for shear. Let's take a look at that. So let's go here, strength limit state for shear. Let's go here. So again, you just have to go through this table. As you can see, each of my tabs is saved for me, so I can go back and forth to ones I created. And here's everything I had for shear. So as you can see, I have these values listed over here. So this is the shear due to the factory load. This value here, this is phi over shear. It's nominal shear resistant multiplied by phi. Then B sub t, this is my projected width of transverse stiffener. And then also over here, I have my moment of inertia for my transverse stiffeners. So all of my results are listed very clearly for each of my sort of elements here. So as you can see, it goes through the entire length of the structure or the superstructure. And then let's go over, for example, if you want to check your service limit state, let's check that as well. So go to design result tables, go to service limit state for flexure. As you can see, it's all listed here. And then it does all the checks here. So here we have one that's no good. We're going to look closely into that, see if there are any more. Here's another one. So, as you're fine-tuning your model, you'll start to sort of get less and less of these until finally, you're ready for your final submission. But, like I said previously, this feature is really helpful in sort of cutting down the analysis times for your designs. Okay, so now, let's see. Okay, so now actually let's go, I think that's about enough for composite design. Obviously there's some other ones I haven't gone over yet, but just in the interest of time, I want to move forward to the cross frames and the piers so that we can sort of end before the hour is up. So as you can see, in order to see any of these other sort of, these other tables, you just have to click on them here and the spreadsheet will be produced for you. So I didn't go over like fatigue or service limit state, or I think constructability for shear, or the shear connectors, or with longitudinal stiffeners, but keep in mind that they're all available to you here just in going through these results tables. So once again, the design process is very simple with Midas Civil. You just click on the tab, and then you go down here and you just enter in all of your parameters. And when you're ready, you can just go on to design, and then all of your results can be printed out into an Excel sheet format. Okay, so now that I've done my composite section, let's go into the cross frame for the steel design, or steel design for the cross frame. So the design steps for doing your cross frame are very simple. First thing you need to do is you need to generate your load combination. So remember when we did the composite design, the first thing we did was we defined our load combinations. So that's the first thing we're going to do also for our cross frames. So let's go to results here, and then go to the load combination tab. Let's actually go back to the model view. There we go. So go to load combination, and then now instead of composite steel design, which we already have, we're going to go to steel design, and we're going to go to auto generation. Okay, so once again, LRFD 12, that's good. And construction stage only, because it's construction stage analysis. And click OK, and then close. So now we have our load combinations defined. So now let's go over the basic steps to specify our parameters. So once again, go to design, go to steel design, and then go to design code. So ash total or FD12, all beams are laterally braced, okay. Steel design, strength reduction factors. So here I have all my strength reduction factors set, just update by code. If you made a change, just make sure to click on this so that everything will be updated automatically for you. That's good. And then let's go to modify steel material. So if you need to make any changes to your steel, so for example, let's go here. That's the sort of steel we're using, that's the code, that's the grade. So all of this checks out. If you need to make any changes, make sure to click on Modify to save your changes. So that's good. So now let's go to, let's see here, let's go to our steel code check. So what it'll do is it'll do everything for the steel members. So right now everything checks out, it's okay. But let's say for whatever reason you need to make a change. You just go here, and then you could go to change, and then you just select, for example, it'll search for a satisfied section. As you can see, I already have this one selected, but if I wanted to change to this one, I could do so, and it would change it for me, so it would switch out the section. So typically I would use this function. If one of these said NG, no good, I would go to change, whoops, make sure to select your section. So go here, go to change, and then as you can see, it'll search for the section that will work for that particular area, and then you can just make the update automatically, and all the sections will be changed for you. So that's another very useful function of the program, is for that iterative process. Instead of having to sort of look for yourself for the section that'll work, the program can just find it for you. So that's another great sort of function of the program. So once you have sections that work for you, let's say for example you want to see some sort of more detailed graphics. So let's take a look at, let's say for example we want to see a specific graphic for the section itself. So what you can do is let's select this section, let's look on graphic. So as you can see, this input menu will come, and I do that kind of fast, so let's click on section, and then click on this bottom left icon here, graphic. As you can see, this window will come up that will tell you all the design information for that section. So here, are all the section properties, the forces acting on it, the design parameters, and also your checking results. So all these calculations are listed here for you along with all the valid values. Okay. And then let's say, for example, you want to see a more detailed sort of result. Just go here to detail, and then this gives a sort of a more in-depth sort of view of all the results. So as you can see, all your properties are listed in the preliminary section. Then as you go further down to the report, you'll go sort of into the results, or excuse me, into the calculations and the results. So it's all listed here. As you can see, it shows you when it checks out, so it's okay for here because it meets that limit criteria. So all listed here very clearly for you. Okay, so this really can, save you a lot of time, especially for larger scale projects where the design process is so long. This can help you a lot with the iterative process. So all these calculations are done for you, and they're all listed for you very clearly. And also, before you X out, it'll ask you if you want to save the file. So here, for example, this is just a preliminary analysis. You don't need it. You just click on No to destroy it. If you want to save it, it'll save as a text document on your computer. Okay, so let's see what else I can show you here. So I showed you graphics. I showed you the details. Oh, and also, if you want to go have like a brief sort of summary of what you had, just click here on Summary. And this just gives a sort of a general overview, everything sort of listed very quickly for your load case factor, your load case name, etc. So that's how you access that sort of spreadsheet. And once again, it'll ask you if you want to save it. We'll click No for now because it's a demo. Okay, so that's how you do basic sort of steel design. Okay, so last to close it off, I'll go over how to do a sort of concrete design for your pier and your pier table, and then the process is pretty much the same as for the steel design. First you have to generate your load combinations, and you have to input your design information, and then you can just view your results. So once again, we'll be going to results, we'll go to load combination, and then now we'll go to concrete. Actually, we'll go to reinforced concrete design, and okay, we'll go to concrete design. So as you can see, I've already generated my loads, just to save time. So it's all listed here, but once again, it's all using the auto generation function. If you need to make changes, you can do so. So we'll close that. And your next step would be to go through design code. So we'll go here. We'll go to reinforced concrete design. Design code is ASH2LRFD. We'll go with seismic zone 2. So once again, if you're in a high seismic zone, or if you need to take into account seismic analysis, just check this on and just select your seismic zone. Moment distribution for the beam, or the moment distribution factor for the beam is 1. And then also, let's go to strength reduction factors here. So these are all set, but if you had to make a change, you would just go here, update by code, and these would change according to the code that you specified. There you go. And then also, if you need to modify our concrete material, so keep in mind, once again, that I'm just going back to this drop-down menu and I'm working my way down. So modify concrete material, as you can see here, here's the type of concrete, the code, and the grade I'm using for my cross beams as well. Code none. Okay. And then also, let's go here, and then if you have a limiting maximum rebar ratio, let's go here. You can make that change just via this input menu. So 0.08 is good. And then also beam section data. Let's go here. So as you can see, you can change your sort of size with this option here. You can change your sort of dimensions, etc., and it will be changed. So these values are good. So 2 by 2, number 5, okay. So we'll go to cancel if you're not making any changes. Now, once again, the beam design is fairly simple for reinforced concrete. So now all we need to do is run the design. So we don't need to worry about any of these particular functions, just because everything's sort of set for now. So what we'll do is we'll go to concrete code design, and then we'll just run the beam design. So it'll run it. There we go. Now this will come up. So these are the beams that we're working with. And if you want to view results, it's the same sort of principle that you use for the steel sections. So let's go here. Let's check one of these on. Let's take a look at the graphic. Or actually, if you want to see the members, if you want like a list of all of your members, you can go here. So as you can see, you can sort them accordingly. So if this is just a section, but these are the sort of the members, or a list of all the members that you're using. So if let's say you want to go to a specific member and see the graphic result, go here. As you can see, this input menu will come up, and it has everything listed as far as your section, your bending moment capacity, etc. So this just shows your results. It doesn't really show like your calculations. As you can see, you can print it easily. You can save it. Now, if you want to go into a more detailed sort of summary, go to the icon here on the bottom left, Detail. And once again, make sure that you have the beam or the element that you want reported on selected with this checkbox here. Let's go to Detail. And now this will come up. And it'll go through, much more detail about, the calculations, factors, etc. As you can see, it goes through all of these calculations here. So check moment capacity, compute shear parameter, compute shear strength, etc. Everything is listed here. Again, all the calculations are done for you in case you want to check. Okay. And then another thing, let's check the summary option. So once again, this is just sort of a brief overview or a brief summary of the loads, the load combinations, etc. And then here are all your values for your checks listed down here. Okay, so I hope you guys, that about wraps it up for now. I hope you guys found this useful. This design module, a lot of our clients are experiencing a lot of success with it. They find that they're using Midas Civil more than ever now because of this. So we really hope for those of you who haven't started using the design modules yet that you'll be able to start using them for your own projects, or if you need any sort of help, accessing the program, or if you need training on these specific modules, just let us know. We can provide that for you. For those of you who haven't had a chance to use Midas Civil yet, definitely we hope that you'll take the time to download an installation, or excuse me, a trial version. Those are free for 30 days. And then, myself or one of my colleagues can assist you through the evaluation, just so you can make sure that the program meets all of the needs that you specifically have for it. Now, if you want to contact me, let me give you my email address. And actually what I'll do is I'll just type a message to everyone. And I'll type my email address in the chat box. Okay, so my email address is dsaraspe@midasuser.com. So feel free to just send any of your questions, any feedback. Maybe there's something I missed that you want to go over, or if you have a question about a specific feature, any sort of question at all, feel free to just send that query over to me, and I'll make sure to address your question as soon as possible. Okay, so yeah, thank you again to everyone for attending this session. I hope you all found it useful. Hopefully, everyone will be able to make it to next week's session. On Wednesday, one of our clients, C.Y. Young from Michael Baker, he actually used Midas Civil for a network tight-arch bridge project in Kentucky. He had a lot of success with it, and he's really looking forward to sort of sharing his experience with you, and to hopefully imparting some knowledge that you guys can use in your future endeavors. Okay, so I hope you all have a wonderful day, a wonderful weekend, and we'll be in touch. Take care.